numbers, wasn't it? 13579. Anyone? Number 1? Anything? Number 3? We're okay. 5? No. 7? 9. All good? Right, okay. So moving on to the next section, equation of a circle with centre 0, 0. Or not 0, 0, sorry. Equation of a circle . Not 0, 0. Okay, and this formula is in the log tables, okay? So the one for 0, 0 is not in the log tables, but the one for not 0, 0 is in the log tables. So we call the centre HK, guys. Okay, and the radius, okay, we call it R again. Right, R, and it's x minus h 2b squared plus y minus k 2b squared is equal to r squared. Okay, so example 1. So find the equation of the circle. And radius three. Right, okay. So find the equation of the circle with centre 2 minus 1 and a radius of 3. Right, okay, so the formula is x minus h to be squared plus y minus k to be squared equals r squared. Okay, so we call this h and we call this k. Okay, so you call the centre hk and r is 3 obviously, so it's x minus h, which is 2b squared plus y minus 1 to be squared. Okay, so the first minus from the formula, second minus is part of k, equals 3 to be squared. So that can be written as x minus 2 to be squared plus y plus 1 to be squared equals 9. And no need to multiply out unless they ask you, and sometimes you need to multiply out, but don't multiply out unless you need to. Okay, is that right? So example 2. Write down the centre and radius. Of, and I'll go x minus 3 right? So the centre, girls, this is minus h. So the centre is hk. So this is minus h. So what's h? Plus 3. And this is minus k. So what's k? Minus 2. So it's the opposite signs to what's there. So plus 3 minus 2. Is that alright? And remember, this is r squared. So what's the radius here? What squared to give you 5? Square root 5. Okay? Is that alright? And we have ones like we had last night as well, you know, the way where you to use the distance formula to get the length of the radius, right? Okay, or the perpendicular distance formula to get the distance from the tangent. So I might do just do one of them, right? Okay, example 3. Hang on now, I find what. Right, okay, so I'll go point. Four minus 3 is the centre of the circle. And we call the circle K. Centre of the circle K, right? Okay, write down the radius of the y-axis is a tangent. Write down the equation of the circle. So the question is, write down the equation of K. Right, a quick sketch will tell you where you're at, right? Okay, so it's a sketch. Okay, so I'm going 1, 2, 3, 4, down to minus 3, minus 1, minus 2, minus 3. So 4 minus 3 is here. Okay, so the y-axis is a tangent. Okay, so that means, remember, a tangent, it's a line that touches the circle at one point only. So look there, the circle, I don't know how big the circle is, but it touches there, right? Now that's really bad drawn, but you get the idea? Yeah, so it touches it at one point only. Okay, so you can tell the radius from the diagram. Okay, right, because look, there's the radius. What's the length of that line? 4, isn't it? So it's cross 4 down to minus 3, so the length of that line would be 4. Agreed? Because we know that point is 4 minus 3. So that means to go from here to here is 4. And it's the same as down here. From here to here is 4. So the radius is 4. Would you agree? Agreed? So write down the centre, or the equation, sorry, so we know the centre is 4 minus 3. So this is h, this is k, so it's x minus h 2b squared plus y minus k 2b squared is equal to r squared. Right, and that would be x minus 4 2b squared plus y minus 3, which is plus 3, 2b squared, is equal to the radius squared, is equal to 4 squared, which is 16. There's my answer. Is that okay? Right, but a sketch can tell you a lot, okay? So that's a chronic sketch, okay? But it is still able to tell me the radius. So if you're not sure where to go, girls, a sketch, right, can really help get it clear in your mind what's going on. Is that alright? Okay. Right, the next thing I want to talk about is the general form of the general equation of a circle. Right, okay, so don't write for a minute, okay? So this is me just, if you were to multiply out up here, right? Okay, if I was to multiply out up here, right, okay, it would be x square the first, twice the first by the second, square the last, wouldn't it? Then squaring this bracket, square the first, twice the first by the second, square the last. And I'm going to bring over that 16, okay, and make it minus 16 equals 0. Is that okay? So I'm going to write the x squared term first, then I'm going to write the y squared term, right? Then I'm going to write the x term, then I'm going to write the y term, and then I'm going to put all my numbers together. 16 minus 16 is 0, so I just have a plus 9 there, right? Okay, so when I multiply that out and tidy it up and move things around, yeah? Okay, I can write it so I have the x squared term, the y squared term, the x term, the y term, the number equal to 0. Agreed? That's the general form of a circle, right? It's basically, this form is handy, the next form is even more handy, right? Okay, so if you multiplied it out, tidied it up, you can write it so you have x squared, y squared, x term, y term, number equals 0, right? Okay, that's called the general form of the general equation of a circle, and it's also in the log tables. So the general equation of the circle is x squared, x squared plus y squared plus 2gx, I'll explain why I'm calling it 2gx now in a minute, plus 2fy plus c equals 0. Okay, sorry, that's a 0. That's called the general equation of a circle. The x squared term, the y squared term, the x term, the y term, the number equal to 0. Right, and I'll show you why I'm calling it 2gx. Why do I call the number in front of x 2g? Why didn't I just call it something x? Okay, the reason is when it's in this form, girls, you don't have to put it into the other form to get the center and the radius. The center is minus g minus f. The radius is the square root of g squared plus f squared minus c. And I'll explain what all that means now in a minute. Right, we'll see it with an example. Okay? So it's just the equation of a circle in a different form. It's just multiplied out from the other form I told you a minute ago. Right? So if you multiply it out, put your x squared, y squared, x term, y term, number equal to 0. That's the general form in an equation. And you don't have to turn it back into the other form to get its center and radius. You can use these formulas to get the center and radius. Okay? Example. Find the center and radius. Find the center and radius. Right, so it's the general form of an general equation of a circle, so it's in the general form, okay? So the other form is handier to get the centre and radius by looking at it, okay? But if it's given to you in this form, you just have a small bit of work to do, right, to get the centre and the radius, okay? So we call the number in front of x 2g. So the number in front of x is 2g. So what's 2g equal to, please? The number in front of x? Minus 2. So what does g equal to? Minus 1. Okay? We call the number in front of y 2f. So 2f is equal to what? 4. So what's f equal to? 2. Right? Okay? So then the centre is, the rule is it's minus g minus f. So the centre is minus g, so it's the opposite sign to what you got here. So minus g is minus minus 1, which is plus 1, and minus f is minus 2. There's the centre of your circle. Okay, is that alright? Okay, so it's just when the circle is given to you in a different form that you're able to get the centre and radius of it. There's a formula to get the radius. So the formula to get the radius is g squared plus f squared minus c. So in this case, it's g squared. So g was minus 1. So it's minus 1 squared plus 2 squared minus c. And c is a number by itself out here. So what would c be equal to? What would c be equal to? Minus 8. So it's minus c. So it's minus 8. Agreed? Okay, so minus from the formula and minus as part of c. Are you all with me? Into the calculator with that. That's 1 plus 4 is 5. 5 plus 8, that's root 13. So the radius of that circle is root 13. Is that okay? Okay, example 2. Wait, let's see. Will I just do another one of them, or do you think we're okay? I thought I'd have a second example, but I don't. As in, I can get one if you want another one of these. Are we okay with that? Do you know what we'll do? Take a minute to do this one. Right, write me down x squared plus y squared minus 4x plus 8y minus 5 equals 0. Write me down the centre and radius. So the centre is minus g minus f, and the radius is g squared plus f squared minus c. So I'm just showing you that example with it, so you have the formulas. They haven't started singing all day. I don't know if they have any classes. They're going like that since 9 o'clock this morning. Like, give it a rest. Done? What you get for the centre? 2 minus 4. What you get for the radius? 2 squared plus 4 squared is 25. Square root of 25, 5. Anyone need me to do any of that out? Okay, right. Okay, I think I'll keep going, so if that's okay. Right, we're all fine so far. Right, the next thing is how can you tell if a point is inside, outside, or on a circle? Okay, right. So points and circles. Right, okay. So what we have is we have a circle. Okay, we'll have they give you the equation of the circle. So you'll be given the equation of the circle. So you won't be given the center, you won't be given the radius, okay, right? You'll just be given a random point. And the question will be, is it inside the circle, as in this case? Is the point inside the circle, right? Is the point outside the circle? Or is the point on the circle? So is the point on the circle? Right? Okay, so you'll be given the equation of the circle and a point. And the question will be, is this point inside, outside, or on the circle? Right. Okay, you can do this without me telling you anything about the next bit. Okay, can anyone suggest how I would figure this out? Right? I'm going to give you the shortcut now in a minute. Right, but the long cut. Right, the long cut, the long way. Right, okay. So what you would do is, you would use the distance, you would get the centre of the circle from the equation. Right, agreed? We're all able to do that? You would get the radius of the circle from the equation, yes? So you'll be able to get the centre and the radius. So I'll just call the centre HK. So you'll be able to get the centre and the radius. Agreed? From the equation. Right, then you'd use the distance formula, and you get the distance from the point to, from the centre to the point. And if the distance is smaller than the radius, what's the story? It's inside the circle. If the distance is greater than the radius, what's the story? It's outside the circle. And if the distance is the same as the radius, it's on the circle. Okay, so you could do this already, right? Okay, using the distance formula. So we know how to get the equation of the circle. From the equation of the circle, we know how to get the centre and the radius. So you would get the centre and the radius, number one. Then number two, you would get the distance from the centre to the point they're asking about. And if it's smaller than the radius, it's inside the circle. If that distance turns to be bigger than the radius, it's outside the circle. And if it turns out to be the same as the radius, it's on the circle. So you can do this sum already. Right, okay. The shortcut is, right, okay, you fill in, right, okay. Yeah, I see. If it's in, yeah, you can only use the shortcut if it's in this form. Hang on now, I just... Okay, right. So we all know the long way of doing it. Get the centre, 3 minus 1, get the radius, 4, get the distance from 3 minus 1 to the point 5 minus 5, compare it to the radius. Done. Right, okay. But when it's in this form, girls, there's actually a shortcut. All you have to do is fill in for x and y. So everywhere I see an x, put in a 5. Everywhere I see a y, put in a minus 5. So I'll get 5 minus 3 2b squared plus minus 5 plus 1 2b squared equals 16. Right? So 5 minus 3 to b squared is 2 squared is 4. That's 4 squared is, minus 4 squared is 16. So I get 20 on this side and I have 16 on that side. Right? Because the number on the left is bigger, right, it's outside. If the number was smaller than 16, it would be inside. And if you ended up with 16 on both sides, it would be on the circle. So if the number on the left is bigger, it's outside the circle, as it is in this case. If the number on the left was smaller, as in what if you ended up with 13 and 16, that would be less than, so it would be inside. And if you end up with 16 on the left and 16 on the right, it's on the circle. Is that alright? Okay. But if it's in the other form, there is no shortcut. So example 2. Circle x squared plus y squared right. The first thing you need is the center and the radius. Okay, can I move it up? Are we all on this example? Are we okay? Right, so the first thing we need is the center and the radius. So 2g is the number in front of x, which is 2, so that means g is 1. And 2f is the number in front of y, which is minus 4, so that means f is equal to minus 2. And c is the number on it by itself, which is a minus 20. Okay, the center is minus g minus f, so it's minus 1 plus 2. Okay, and the radius is the square root of g squared plus f squared minus c. Which is the square root of 1 to be squared plus minus 2 to be squared minus minus 20 into the calculator, press equals, that's 5 plus 20, that's square root of 25, which turns out to be 5. Is that okay? So I'm comparing, right, the distance, so the center is here, which is minus 1, 2. Oh, will you shut up? The radius is 5, right, okay, and I have a point 36 and I'm trying to show it's outside the circle. So what will I do now? What will I do? How will I show it's outside the circle? I get the distance from the center, which is minus 1, 2, to the point 36. Distance formula, x2 minus x1 to be squared plus y2 minus y1 to be squared, x1 y1 x2 y2. So it's the square root of 3 minus 1 to be squared plus y2, 6 minus 2 to be squared. That would be 4, 16 and 16, that's root 32. In your calculator that would be 4 root 2. Right, and 4 root 2 is square root of 32 is probably 5 point something. Dot 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 dot. Turn it into a decimal. It's bigger than 5 anyway. Okay, so then you'd write a sentence. Because the distance is greater than the radius, it's outside the circle. Is that okay? You can't spell. So when it's in that form, girls, there is no shortcut. When it's in the other form, there's a lovely shortcut, but no shortcut here. Right? Is that okay? So we're going to do page 425 to 426. Let's do one.
We're selling raffle tickets for Bernardo's.
Yeah, and tickets are euro, and the prices are outside the euro office. If anyone wants to buy a ticket now.
Okay, thank you.
1 to 14, girls. Just do the even numbers. Right? Okay. So just do the even numbers tonight. I like to shake it up a bit, keep it exciting. We did the odds last night. It's very exciting, isn't it? 1 to 14, just do the even numbers. Okay? Right?